Hello students. In the last video we discussed the periodic tables, how the periodic tables we can form, and lantern and actin remembering tricks. And today we discuss the periodic properties. Periodic properties mean in the periodic table the elements, how they behave, how their properties, how they are similar, and how their properties change within a group, within a period, and all these. So let's start. First, ionization energy. We know the amount of energy required to remove an electron from its outermost orbit of an atom is called ionization energy. That means the energy that required this electron to release from the out. That means the energy that required to remove this electron from this orbit is ionization energy. The unit of ionization energy is kilojoule per mole or simply electron volt. Suppose a gaseous element M, when we give the energy, then it gives an electron and the element is plus charge. So one electron is released. So that here one charge. So this energy is called ionization energy. This is the fast ionization energy because this energy required to release only one electron or fast outermost electron. But when the successive electron, that means from M plus to M2 plus, the second ionization energy, that means energy required to remove the second electron from the last orbit, that is second ionization energy. After that, nucleus contain, we know that nucleus contain proton and neutron, so it is positive charge. This nucleus contain proton and neutron and this outermost electron. So due to neutron and proton, this is positive charge, and the electrons are negatively charged. So there is an attraction between the nucleus and the removed electron. This is positive charge, this is negative charge. So there is attraction in between these two. So when we apply energy to remove an electron from the gaseous atom, it is easier than the next one because the outermost electron is loosely attracted by the nucleus. This statement means that when we first remove this electron from this orbit, this is easier than the removing of this electron because this attraction between this electron and this nucleus is less due to presence of these electrons in between these two. But when we try to remove this electron, then this is nearer, so that this attracts more than this one, so this takes more energy to remove this electron from this orbit. So fast ionization energy always lesser than the successive for an atom. So order of ionization energy, fast ionization less than second is less than third, and like this continues. But the change in ionization is opposite order. We see that E3 is greater than E2 greater than E1, but here it is changed. The del E1 is greater than del E2 is greater than del E3. Here del E1 means ionization, second ionization energy minus fast ionization energy is the change in fast ionization energy. So this order, you have to remember this. In periodic table, ionization energy increases from left to right across a period but decreases from the top to bottom along the group. The reason is that this statement said that when we go to period from left to right, then ionization energy increases, but when we go from top to bottom, then this is decreases. The reason is when we go from left to right, the periodic table electrons are added in the same cell, so there is increase in attraction between the nucleus and electron, hence ionization energy. But when we go from top to bottom, then the new cells are added, so less attraction and hence ionization energy. That means this statement said that when we go to the periodic table left to right, then additional electrons are added in the same cell, so there is attraction. But when we go from top to bottom, then new cell added, so due to new cells there is distance increases, so that this ionization energy decreases to the decrease in attraction. Then there is some exception to this rule. This figure shows that when we go from left to right in the periodic table, then ionization energy increases. When we go from bottom to top, then ionization energy increases. This is a short trick, L. You can remember L. That means this is L, and arrow mark means from here to here. That means in periodic table, bottom to top, ionization energy increases, and from left to right, ionization energy increases. And there is some exception. The irregularity of ionization energy is explained on the basis of empty half field and completely filled configuration have extra stability. But there is some exception. That means this rule, this L rules exception. Due to half filled and full filled, there is some exception. When full filled, then it is required more ionization energy than the other. Suppose beryllium boron. Boron has higher, we know that's beryllium 4, boron 5 atomic number. So obviously this rule, according to this L rule, this boron have higher ionization energy, but due to this is full filled orbital, so this 1:2:2 and electron configuration here 1:2:2p1. So this last electron is fulfilled, so it required more energy to remove an electron from outermost orbit, so that the barium is higher ionization than boron. This exception explained here. And another star mark, that means remember ionization value for noble gases are highest. Here is a, because noble gases are full filled orbital and they have inert pair configuration ns2 and np6 configuration, so that their last orbital p6, that means totally filled, so that it required higher energy to remove an electron, so that this ionization value for noble gases are highest. Next we go to the electron affinity. Electron affinity. What is electron affinity? The electron affinity is defined as the amount of energy released when an electron is added to a neutral gaseous atom. The ionization energy is just opposite of electron affinity. That ionization energy is the amount of energy required to remove an electron, but electron affinity is the amount of energy released when one atom is added in the outermost orbit. So the gaseous atom gains one electron, it have x minus, and energy is released. The greater the electron affinity, the greater, more negative is the daily value, and greater is the energy release. When electron affinity increases, that means more energy required, more energy released to add an electron, so energy is also negative. And another thing, in ionization energy, the noble gases have highest ionization energy, but in electron affinity case, noble gases have 0 electron affinity. This also obeys same rule. When we go from left to right in periodic table, electron affinity increases, and when we go from top to bottom, electron affinity decreases. This electron affinity depends on the two factors, size of atom and effective nuclear charge. Atoms with small size and high nuclear charge shall have high electron affinity. The atoms with a small size and high nuclear charge shall have high electron affinity. When an atom is very small, then addition of electron can repel. Suppose this one, an atom, nucleus, electron are there present, and when we try to add this electron, then this electron repel, so that it requires more energy. We have to overcome the repulsion energy to add this electron to this subshell. But suppose here Morse orbital, Morse subshell, so addition of this electron does not require so much energy, because this electron far better, so this nucleus attract these two, so these electrons are free, so that this is not so repulsion. So here required more repulsion, so more electron affinity is required. So small size and high effective nuclear charge have high electron affinity. one question is there. The most electron affinity of the following elements is that. This is your homework and you can do it after reading all these, and I will give the detailed descriptions in the description box. I will give the playlist of this periodic property and all the last video in the description box. And I think you understood, and do subscribe my channel. Thank you.